Howdy students. First review, here we go. Distribution, we're going to grab that number that's on the outside and we're going to push it to both terms on the inside. Watch your positives and negatives. So on this one, we've got negative 10 times x, negative 10x, and then negative 10 times negative 7. So positive 70. On number 2, we're grabbing this 6 and we're taking it to both terms inside the parentheses. Notice there's 12x not inside the parentheses, so we're going to leave it alone. I've got 30 minus 6x and then plus 12x. Now here, you've got negative 6x. We're going to combine that with a like term with 12x. You can think about it as 12x minus 6x if that helps you out. 12 minus 6 is 6. And we got that answer all done. This one, negative 2. That minus 2, we're going to use a negative 2 to distribute for that reason. So I've got a 9 on the outside. Nothing's happening to that 9. Minus 2x, and then negative 2 times negative 4 is positive 8. And so I've got 9 plus 8, 17. And then that negative 2x still hanging out in there. Box those answers. Feeling better about that already. 5 goes to the x, 5 goes to the 11. So I've got 5x, 55. Box that bad boy up, we're done. Undistribute, finding what's common between them. Alright, finding what's common between them. This is 6 times s, and this is 6 times 7. Alright, so both of these have a 6 multiplied into them. I'm going to pull that 6 out, and this is what's left over. Same thing here. It's a little bit easier to spot in this problem. They both have a c multiplied into each term. So I'm going to take that c, I'm going to pull it out. Those are my two undistributed answers. Is it a function, why or why not? I'm going to do both of them at the same time. For this one, every time I have x equal 1, y is going to be equal to 8. And every time I have, let's just pick another one, every time I have x equal to 7, y is going to be equal to 8. Now it doesn't matter that this 8 duplicates here. What matters is that every time I choose 1 for x, I know y is going to be 8. Doesn't matter how many times I choose 1, always going to get the same answer for y. This makes it a function. Down here, you'll notice if x is equal to 3, I've got two choices for y. When x is equal to 3, y could be 1, or when x is equal to 3, y could be 4. This is not good. Alright? Not a function. So because of that, because you have an option for the y to choose, not a function. You want to have a for sure answer for y every time you pick a specific x. Give 3 names for the x value. They can call it the domain. They can call it the independent variable. I don't know if I spelled that right. And they've got the input. For y value, you've got range, you've got dependent variable, and you've got output. And those are your words for there. Sliding down, let's go to that next page. Starting with number 11. Hot dog business taking off. Charge $20 to set up, $15 an hour to run the grill. You want to make business cards that show the total cost for 2, 4, 6, 8 hours. Identify all this kind of stuff. Equation, we'll use x and y. Well, I'll tell you what. We'll go cost in hours. So your total cost is equal to $20 to set up plus $15 per hour. The independent variable, the variable that you need to know first, is the hours, and it's inside your equation. That helps you out. So h is going to be the hours, and your dependent variable, depending on how many hours you work, that's going to be your total cost, your total charge. Input, output table. So for my hours, I'll go 2, 4, 6, and 8. They tell us to use those right here. And for my cost, it's going to be 15, so 50, 80, 110, and then 140. All right, and you can do that math. This is just, C is equal to 20 plus 15 times 2, and then 15 times 4, 15 times 6, and you'll get those numbers. Identify the range. I'm going to use set notation. My range is going to be just the cost values. So 50, 80, 110, 140. That's my range. It's going to be my cost. Business model. Your business is taking off. We want to charge more. Which fee could you increase by $5 to pull in the most money? Why? I think you guys know this one. It's the hours, all right? The reason we want to increase the hours is because the one-time cost, you only get that $5 the one time. But if you change this hourly rate to $20, every hour you get an additional $5. All right, so our new cost is going to be $20 plus $20 per hour. And that's going to give us an extra $5 per hour as opposed to $5 just one time. Next page. Solving the equation for x. All right, first step, want to get x by itself. We got currently this 6, it's cramping our style. We're going to remove it from the side of the equation that's got our x. So cancel out with a minus 6. We've got a negative 3x, and it's going to be equal to 12 minus 6, which is just 6. I now have a negative 3 attached to my x. I want it gone. So I pull this negative 3 off. X is going to be equal to negative 2. Ready to go. This one. Again, look for things that we can move real easy. This minus 1, real easy to move. I'm going to add 1 to both sides. Balanced, so I know I'm ready to go. And I'll have 12 is equal to x over 3. Now I've got x divided by 3. Want to get rid of that. Multiply both sides by 3. And we're ready to go. X equals 36. Moving on. Now this negative 2 is dangerous. Dangerous. Alright? We want to make sure we keep track of that negative sign. I'm going to distribute the negative. So it's going to be 7 minus 2 plus 2x. That's the one that gets a little crazy. You got the double negative. Going to turn that x positive. And then we're just reducing. 7 minus 2 is 5. And then I want to pull that 5 from both sides. Again, checking to make sure that's balanced. 5 from the left side, 5 from the right side. Looking good. Watch those negatives. They get a little crazy. Divide by 2 to finish off this problem, and we're going to x is equal to negative 4. Next problem over here. This one, even more dangerous. I know. I'm going to sneak in a negative 1 right there. It'll give me something to distribute. So I've got negative 1 times 3. And I've got negative 1 times negative 5. So that's going to be 3x plus 5 minus x is equal to 15 minus 3x plus 5. All right, be careful with that negatives. Now we got to start combining some terms. So I'm going to take the 3x minus x. I'm going to push those together. That'll give me 2x. The plus 5 is just kind of hanging out on that side. And then I'm going to add equals 15 plus 5. These are the two I'm going to push together. I'll get 20 minus 3x. We have a choice now. I want to get my x's on the same side. I'm going to move the 3x. The reason I'm going to move the 3x instead of the 2x is it'll force my x's to become positive. All right? If I minus this 2x the other side, I'm going to get negative 5x on this right side. Not something I want to deal with. Always trying to keep my x's positive makes my life just a little bit easier. Move that 5 at this point. 5x is equal to 15. Divide the 5 off. X is equal to 3. And we're all done with that problem. Sliding it on down. Alright, this one, 2 steps. Some of you may be tempted to take care of this fraction all at once. Do not be. I would always split this up into 2 pieces. Multiply by 4 on each side. Cancels on the left side. Grabs and turns that into a 40 on the right side. And then divide by 5. You'll get x is equal to 8. You can always use reciprocal fractions. Multiplying by 4 over 5, that's fine. But more dangerous. I would rather have 2 fast steps, easier to be accurate with, than 1 big step that I could mess up. Next one, going to add the 7 first, and we're in the exact same situation we were in over here. We got a fraction with our x. I'm going to take care of the denominator first because it's a little bit easier to do. I'll get 36 is equal to 2x. Pull that 2 off, and we'll get x is equal to 18. We'll cut the video here, keep it under 10 minutes, and we'll start up on the next one.